This is AdPriva console, a privacy-first ad verification platform deployed on Horizen Testnet. I'll demonstrate how we verify ad engagement using cryptographic proofs, zero-knowledge verification on zkVerify, and blockchain anchoring, all without collecting any personal data. Let's log in. First, publishers register their sites by adding a domain. To verify ownership, we provide a unique verification meta tag that the publisher adds to their site's header. For example, this is our GitHub test page where we've added the meta tag. Once verified, the site shows as active. Publishers create ad placement and receive an AdPriva tag, a JavaScript snippet they add to their site's header. Let me show you how it works. Here, for example, a 300 and 250 banner slot on a test site. Let's get the tag. Let's copy it. Here's the tag we've added to the header of the test page. This tag captures ad engagements and sends them to AdPriva without using cookies or collecting personal data. This dummy image represents an ad. Once we integrate with OpenRTB and DSPs, this placement will serve real ads, either contextual ads based on the page content or ad categories chosen by the user through the AdPriva ID app. When a user views or clicks the AdPriva tag sends the event with no personal data whatsoever. No IP addresses, no cookies, no device fingerprinting, no identifiers. Only anonymous metadata, event type, timestamp, and placement ID. Every event is signed with HMAC on the server side before being stored, ensuring cryptographic integrity from the moment it happens. Now let's see what happens when someone views or clicks an ad. When the user interacts with the AdPriva tag generates an engagement proof. A signed event created instantly and converts it directly into a cryptographic proof. We don't store any raw events or personal data. Proofs contain only minimal anonymous metadata, the event type, timestamp, and placement ID. There is no IP address, no cookies, no fingerprinting, and no identifier stored at any point. Here's where privacy meets verification. When the tag sends an engagement event, proof, our server creates an HMAC signature using a platform secret key that never leaves the backend. At regular intervals, AdPriva batches these proofs and hashes them together using the Poseidon hash function. Poseidon is a zero-knowledge friendly hash used to build efficient Merkle trees. The result is a single cryptographic commitment, the Merkle root, which proves this event happened without revealing any individual event data. Each Merkle root is submitted to zkVerify, where a GROT16 zero-knowledge proof is generated and verified off-chain. After verification, zkVerify anchors the result on the Horizen Testnet, giving us permanent, publicly verifiable record. Here, you can see the zkVerify receipt, the job ID, the verification status, and the associated transaction details on-chain. Anchoring happens automatically after zkVerify finalizes the proof. Horizen acts as the immutable settlement layer. Once a Merkle root is anchored here, it cannot be modified, creating a tamper-evident audit trail. Here you can see the transaction details on-chain, proving exactly when this batch was anchored. Anyone can independently verify this Merkle root on-chain, confirming that the ad engagement happened exactly as claimed. Here's the complete privacy architecture. Ad events from the AdPriva tag are converted into HMAC signed proofs, ensuring integrity from the moment they're created. These proofs are then batched into a Merkle tree using the Poseidon hash function. zkVerify generates and verifies the zero-knowledge proof from the batch, and finally, Horizen anchors the Merkle root on-chain, making it immutable and publicly auditable. At no point do we store cookies, IP addresses, device fingerprinting, or any personal identifiable information. Everything is anonymous, cryptographically secured, and verifiable. AdPriva's MVP is now fully functional and now in beta, live on Horizen Testnet and zkVerify Testnet.